robotics is and who this guy is and what he does.
Hi, everybody. So like I said in the last video, I'm Alan Gregory. I'm a mentor for the first robotics competition team. What that is we're basically a large program that's international. First is for inspiration and recognition of science technology. We're trying to get more and more students interested and excited about STEM through competition robotics. So instead of just like a science fair where you might do a project, you might learn a little bit about science, we're actually having them compete against other students in a game that's designed every year. So basically like robot sports. We'll be working through different challenges. There's an entirely different game every year. You may see behind us and through the clips they're going to be showing robots shooting balls into towers. There's robots shooting footballs. We've had to shoot frisbees, yoga balls, stack bins. Every year it's a brand new game. With that, we get students excited, we get them interested, we get them learning different things about science, different things about engineering, getting them the introduction that they need to hopefully find their hopeful career choice.
So what are you guys doing specifically here at the Maker Faire?
At the Maker Faire, we're trying to get more people awareness, right? We want them to know that these are going on. We want these to know that these are available for their students, that they could start teams all the way from kindergarten through high school. They can be working on robots after school. They can be doing it as a community program. There's lots of ways to get students building robots and competing with them.
Wow, all right. Well, how big is FIRST? How big is the competition?
FIRST is a pretty big competition. So it actually ranges, like I said, all the way through kindergarten through high school. So the robots that I mostly spend my time with is the FIRST robotics competition. That's like the varsity level of what we do with robots. So there's some JV ones, there's some little programs. FRC is 3,500 teams worldwide. There's teams from Brazil, Israel, China, and a huge number from the US and from Canada.
Wow, all right. Now, let's see, you said people like China coming over?
Yeah, so China's actually really interesting. I don't even think we've talked about that yet. So in 2015, we got to go, or myself and a few other teams from Texas and some of my students got to go to China to work with some of their students to teach them how to do FRC and to compete with them at one of their off-season events. So we got to spend 2 weeks in Shenzhen, kind of touring around China a little bit, learning from their culture, learning from them, and then teaching them how we build robots.
Oh wow, that's impressive.
Yeah, and China's actually getting their first regional this year, so they'll have their own official competition instead of just like a summer practice event. They'll have a real one for Chinese teams this summer or this fall.
Wow, that's pretty impressive on their end to start adopting all this kind of thing in philosophy. So it's interesting that it's going to be a thing that's going to be globally recognized, you know?
Yeah, it's a big thing. So they'll have world championships. So we've been having world championships since about 1997 when we started getting international teams, and they've been growing and growing. This past April in St. Louis, we had 600 teams go in the same place where the St. Louis Rams play. So we take over the entire dome.
600.
600.
Wow.
So it got so big that this coming April for the World Championship, they had to split it into two. So we're going to have one in St. Louis for 400 teams, and there'll be one right here in George R. Brown in Houston for 400 more teams.
So, moving forward with the whole Houston aspect, how much of this is going to be centered around here?
Because the World Championship's coming in, we're seeing a lot more from FIRST headquarters, the organization. It's centered out of New Hampshire, where they're getting more of their people down here often, talking to companies, working on getting sponsorships. And what that's doing is it's getting more employees to know about it and getting more and more teams in the Houston area. We already have 40 to 50 teams right now at the high school levels in greater Houston, right, whatever, all the way out to the suburbs and everywhere else.
Wow.
But we're getting more and more, and hopefully it'll be expanding from there.
All right, man. So can you describe the challenges a little more in detail that you guys do during these competitions?
Absolutely. So this is probably the hardest challenge any of these kids will see, possibly up to and including their senior design project in high school or in college.
Wow.
Because they're having to build a robot that does some sort of actual task in game. And it's not just does it have to complete the task, it has to do it while going against other robots. So for each game, we have 3 robots on an alliance versus 3 others. So for every match, you're randomly paired with 2 other schools or 2 other teams. You have to quickly design a strategy for that match and then compete against 3 other teams. So they may be stopping you from scoring. They may be running into you, playing defense just like you would in football. And so it's a lot more dynamic than just a science fair or solar car or any of those other STEM activities.
Now, how big are the teams on average?
There's a pretty wide range. Average around 25 to 30 students, plus 4 to 5 mentors, normally engineers, teachers, those types of people helping out as well.
Wow.
And the mentor side of it is a big part. Because you're getting to have students, not only are they working together, but they're working side by side with their engineering mentors. So it's not just the students building everything and their teachers teaching them how to do it or anything. I often, as an engineering mentor for the team, will send stuff to the students, ask them for their input and review. I'm not always right. They're not always right. This is very much a team concept through and through. Everybody on the team, adults, students, everyone working together.
Now, as far as tools go, are you guys using things like AutoCAD? What kind of software and hardware are you giving the kids access to?
And that's one of the things that's grown a lot since I first started. When I started in high school about 15 years ago, we were not really CADing much of anything. We were kind of doing it all we were drawing stuff out on the board, drafting a little bit, but just kind of going at it.
I remember
and
that.
We had some little bit of CAD, but we weren't doing much of it to actually build the robot. Now, the first thing we try to get our kids to learn is SolidWorks. So we're doing full 3D models of almost every part of the robot. We're able to do 3D printers, CNC routers. We have sponsors who help us with laser cutting and CNC bending, so they're doing full sheet metal design.
No way.
They're doing all of these things at the high school level, and by the time they come out, they're SolidWorks experts through and through.
That's pretty impressive in itself. I remember being in high school with this program, and oh man, dude, we were writing everything out on paper. It was rough, man. Like I'm no Rembrandt. I am not very inclined. I was hardcore with the ruler, everything, and
yeah, we did a lot of drafting. I remember we even had a class in basically drafting and things, and we did it as much as we could. But now it's so much easier being able to have the computer power and be able to 3D model things, and just that knowledge, and with all of the improvements in CNC design and 3D printers and things, these are stuff that the students will be able to use their whole life.
Nice. So, what about physical tools? You know, like you talked a little bit about the software there. Now, what kind of things do they get their hands on as far as? You mentioned a bit there about benders and things like that.
So this is one of this is kind of the saving grace for your school shop that has been getting removed from more and more schools.
Wow.
We just built at Strake Jesuit and St. Agnes, we actually just worked on getting a brand new STEM building that has all their physics and chemistry classrooms. But in addition, it has our engineering lab and our engineering computer lab right next door. So in the engineering lab, we put in basically a full machine shop, lathe, mill, CNC router, 3D printer, dust collection, air compressor with inline air, all of that. Basically, we built in a shop so that we can start bringing back these things, because this is what engineers need to know going forward.
No, for sure. What I can definitely verify is that a lot of engineers out there have not ever had their hands on tools.
Yeah, we get so many students who are, I'm even amazed. We're like, lefty loosey, righty tighty, right? Like we got that, and they were amazed that they don't. So we'll take them all the way from there to when, in a couple of years, even that year, they'll be operating a lathe and turning parts and bandsaws, drill presses, all of that kind of thing, grinders, whatever they need to do to make the stuff work.
Yeah, and really getting the small nuances of workplace behavior and things like that are important too. We're talking, I've seen people who don't know how to open a bag of zip ties properly, right? So they just cut the top off, and then all the zip ties end up falling out on the floor. It's like you're supposed to tear it at the middle, man.
Yeah, they work through shop organization. Yeah. They work through all of those things. We actually, one of the big things with here is the service aspect of it too. So not only are these students learning about robots, but we're helping these younger students or the younger competitions and other robot competitions. So they'll volunteer as referees. They'll volunteer to help do a field setup. They volunteer. We do a lot of AV, so they'll even stream the events. They'll learn about the live streaming stuff, photography, web design. All of those things come into it.
Now, what are you guys live streaming this on? What platform?
Normally our stuff right now is on YouTube, but we've done things on Twitch as well. You'll see it in quite a few different places.
Promotions and things, man. I've never really heard of this event, and I live pretty locally.
It's tricky to get press, right? We're entirely a nonprofit organization. We're out of the schools. The main nonprofit is out of New Hampshire, so we can't really buy media time, right? You're not going to see us on your primetime commercials or anything like that.
That's fair enough.
So what we're able to do is we try to get out into the community as much as we can. So we'll be at demos like Maker Faire, Comic Palooza. We have a pretty big presence. We bring out the field. We'll try to go to corporate events. We'll go wherever anybody's willing to have us, basically, to spread the word and get more schools out there. We'll present at schools a lot too to get them there as well.
Okay, so are you guys on social media like Twitch or anything like that?
Absolutely. So almost all of our FRC events are live streamed either to Twitch or YouTube. We're also, our team specifically is Spectrum 3847, so at Spectrum 3847 on Twitter, Spectrum 3847 on Facebook, any of those types of places. Instagram, you can find pictures of robots all over the place. First, the organization, the national organization or international organization, is at firstinspires.org is the main website, but then they're at First Tweets on Twitter. You can get them on Spectrum or on YouTube as well. And you can get videos of robots playing all the games, all the history. One of the really cool sites, if you really want to get into this and dive deep into the data and see how these robots work, is called thebluealliance.com. That's the big archive website for all of the stuff that we do. So you can pull every match from every year for every team. If you might have a cousin who's been on this thing, you can find them and watch their robot play the games and things like that too. It's a great source.
So bluealliance.com?
TheBlueAlliance.com.
TheBlueAlliance.com. All right. Don't forget that. Continue the trend here of, we're talking about the whole social aspect. What about volunteer work? You guys get a lot of volunteers coming through here?
We do. We always need more. But we can use volunteers for anywhere from the really dedicated people who want to be engineers and want to mentor the teams. We could always use those at local high schools, elementary schools to do that. But we also need volunteers just to work some of our events. So we'll have 60 plus robots at an event. So we need people who can ref, who can queue, so just making sure the robots are on the field at the right time. We get field technical advisors who are helping us with the communications on the field, making sure all the robots are able to connect to the Wi-Fi network that we use, all of that type of thing. So if you have a technical background and you want to help volunteer, this is a great way to do it.
Okay, that's pretty awesome. So I'm assuming with all the volunteer work and the fact that you get these big teams together, there's a lot of teamwork and cooperation that's going to go into everything.
Yeah, the students get a crash course into how to work as a team in the same way that they'll eventually be doing at organizations, hopefully in their careers. So they have 30 to 40 students per team, all working on a singular project. And you have to get everyone to agree. You end up building out the hierarchies where you have different people working on different subsystems. You might have people working on the drivetrain or the intake that's going to collect the ball, the shooter, whatever the object is for that year's game. Right? They all divide up things. We have some people who may not even want to be on the engineering side of it all, and they'll work on the website or do other things. But all of these people end up working together. You have people from all different backgrounds, and you're learning to be on the team, and you're learning also how to lead the team as well. So you get leadership experience. They're working with other schools from all over, and other, like we said, it's an international program. So there's sometimes where you'll be on an alliance where you may not even be able to talk to them because they only speak Spanish or some other language. So you're learning how to get your word across in strategy design very quickly, so that you can work together and still have a successful match.
So regardless if any of these kids moving forward decide to have a career in the technology department or not, at least at the end of the day, they're getting tools and skills necessary for community and teamwork.
Absolutely, yeah. They're becoming, they're developing into adults. Like, we basically take people who were just out of middle school and get them to get put into an adult environment in a project in the same way that you would be working on for any sort of product development or anything like that. We have to rapidly do it. We only have about 2 months to build the robot, and then we start competing. They have to iterate on it. So if they fail, if something breaks, they have to learn how to make improvements. They have to just figure out the problem, think of what the solution is, actually implement it quickly. They have a ton of pressure on them. So for every match, they have drivers that have to drive the robot in the same way that, like, the quarterback of the football team is responsible for a lot of it. Our drivers are that same type of role. They have to make sure that they're trained, they're ready, they're focused, because everybody who's all that work for 2 months for 40 people is on their shoulders for every match to make sure they're going to be effectively maneuvering the robot, doing what they're supposed to do, and executing the strategy.
Wow, all right. Well, sounds like you guys have a lot going on, and I'm pretty excited about this. I plan on watching this in the future, and I'm very excited that's local to me. Sorry for you guys out there, you're going to be missing out a little bit, but hopefully you'll be able to catch it online, right?
Absolutely, yeah. There's tons of places to watch it online, and it's a worldwide competition, so there's regionals all over the country.
Sweet. Okay. Yeah, I think So, who are you? Why are you here?
My name is Mary Wynn, and I'm from the Spectrum engineering team from St. Agnes and Strake Jesuit.
Okay.
And I have been on the team for 4 years, and I'm currently a senior.
Okay, currently a senior, huh? So you've been on this project for about 4 years now, right?
Yep.
How did you hear about this project?
I heard about this project from my friend who's already on the team. I wasn't really interested in engineering, but I was like, why not? I'll just try it for a little bit. And ever since the day I joined, I never left because it was so interesting.
Wow. So when you first got in there, what was actually something that kept you around? What kept your interest?
The thing that kept me around was the mechanical part of everything. I had never learned how to do any mechanicals or work with computers or technology or anything of the sorts. So when they let me touch all these gears and motors and let me play around with it and taught me how all these things moved, how gear ratios worked, how motors worked, I got so intrigued because I had never known that the world was so interesting and like how all these things had worked and how it worked, like how cameras work or how the motors worked. It was really interesting.
So what are some of the projects you work on?
Well, the projects that I work on from freshman year, what we first did was that we had a bunch of gearboxes that need to be built, and that was basically my first project that I did that kept me in the program and stuff. And from then on, as I got older and more experienced in the program, they gave me more responsibilities, and I did things like I formatted trading cards that we made on Inkscape, one of the programs for graphics, and it taught me how to learn and use the graphic program Inkscape. I also took on projects such as making a powder coating box where we would keep our powder coated things in there. But basically we got our sheet metal and we put it in this box and we'd spray it with this powder and we'd bake it in this little oven, and I built this box so that it would be easily accessible to turn the metal around and things like that.
Okay. So what are some of the kind of tools that you guys get to work with in your program?
The best thing about our lab is that we get so many tools to work with. We have things like a CNC router that we have a computer next to it, and I know how to work that because Alan, our mentor, took some time and sat down with me and taught me how to go through all the process and make the CNC work basically. And we also have a 3D printer, which I have made various times on different occasions on the CAD software we use. And we have a mill, we have a lathe, we have a horizontal bandsaw, which I love because it cuts things straight, and it's amazing. I love it.
Convenient.
And we have, what else do we have? We also have a brake, which bends metal.
Yeah.
And we also have a circular saw, which I'm kind of afraid to use, but Alan's taught me that I shouldn't be afraid because, it has a lot of safety measures, but you can't be too sure with a big saw blade just pointing at you, so.
Yeah, that can be pretty intimidating in itself. So you talked a lot about the hardware tools. What about the software tools?
The software tools that we use are SolidWorks. SolidWorks is the CAD program we use to design our entire robot. And I have learned so much about SolidWorks from freshman year. In freshman year, we didn't have a lot of computers to use because we were building in our old lab, and we didn't have a lot of access to computers, and I would occasionally do SolidWorks. But as we got to the new lab that we have, there's an entire computer lab next to it, so I got to use SolidWorks on a daily basis now that we have this computer lab. And I've also used Inkscape, which is a very, very simple graphics program that Alan introduced me to. And with this graphics program, I help make graphics on the teams, from our borders to our flyers to our backgrounds, things like that.
Right. Okay, so is that program using like vector graphics or what?
Yeah, it uses vector graphics.
Yeah, what is it like being on these teams? I mean, what do you have, like 20, 30 people on your team?
We have 20, 30 people on the team, and I love this team so much because there's several other teams all around the world who have large teams, but our team is smaller and we really get to know each other and we learn a lot from each other. So if I might not know about computers, there's always going to be another guy on the engineering team who's going to know more about computers than I do.
Okay.
And we also help learn from each other how I might help the underclassmen with their public speaking, and I might teach them how to do to fix the robot, and it's helped with my leadership skills a lot too.
Okay, yeah.
And our team is very special because in our 6-week period when we're building our robots. We meet every single day. So you really get to know the people you meet every single day.
Okay. Now, moving forward with everything, where do you see yourself going from here? Are you going to continue to volunteer for this after you graduate? Or are you just going to move on to college? Or what's the plan?
I can definitely see myself volunteering more for this competition because by then I'll be an adult and I get to volunteer for the adult things. Like, I can be a ref. A ref is the person who knows so much about the game, and I've always seen those people. I mean, like, I want to know as much about the game as they do. And I will definitely volunteer because it's so fun. Even volunteering as a student, it's been an exciting experience. And I also, because of this engineering program, I want to pursue a career in mechanical engineering. I am thinking about going to A&M and majoring in mechanical engineering from there.
Okay.
Yeah.
Well, sounds like you got a bright future ahead of yourself. I mean, you've gotten a lot of tools and experience, and I'm sure it probably looks good on a college resume, the fact that you've worked on such a large-scale team and you've had a set of mentors that has a very heavy engineering background.
Mm-hmm.
So, I mean, all in all, I think this is a pretty awesome thing. Everyone should really be supporting this at this point. I've never even heard of this until this Maker Faire, to be quite honest with you. I have no idea. I mean...
It's so cool!
Yeah, and really what's kind of startling to me, I was talking to your mentor and I was telling him, I was like, man, we need to get some kind of social media coverage out there. People need to be sharing this. Everything that people can be doing at this point. And I think it's just going to take a matter of time.
Yeah.
And very excited about it. Thanks for being on the show, Mary.
Thank you for having me. Thank you.